Hi and welcome to 2024 question C2, the structural forms question. So the image on the right shows a golf practice net. The shape of the net is based on a hyperbolic paraboloid. Projections of a similar practice net are shown in figure C2, down here. The surface of the net is formed by extending the hyperbolic paraboloid surface ABCD. So ABCD, ABCD, and we can see we've extended it there with some elements. So draw the given elevation, including the elements as shown. So draw this bit to begin with. All right, so we've got a scale 1 is to 10. So everything here we're going to divide by 10. Right. Let's start by drawing that base part. So it's radius 70, sorry, 75, so 15 across. Mark that off, and 15. And we're going up. $55. And my center. And a radius of 75 then. Okay, and drop that down. Okay, so there's the outline, and now we want to draw ABCD. So A is actually straight on up. There's A. C is going to be down a distance of 30 to C. And we're going to be going up 30 and we're coming out, it's 110, so 55 each side. 55, so that's my D and B. Okay, we'll join those up. I'm actually going to use a color just to highlight this a little bit, so I'm going to go ABC. Okay, and include the elements. So we also have to find these elements. So I need to divide lines into equal parts here. So just do a construction for that, and it's going to be into 1, 2. If you look along, we got 1, 2, 3, 4, 5. So divide it to 5 equal spaces. So I'm going to step off random distance and step it off 5 times. So 1, 2, 3, 4, 5, and we'll join the last point onto D. Use sliding set squares then to find the divisions. Okay, so I've divided that into equal parts, and now I'm going to do the same on this line. Actually, I'll just do the construction on this side as well. So from A, line at a random angle, step off 5 distances. Let's change that. So 1, 2, 3, 4, 5. Join that back to D. Slide and set squares. One, 2, 3, 4, 5. Okay, so it's divided both those lines up into equal parts. So now I just need to find the corresponding points. So it's the points, just marking off the position there. That will make life easy for me now. And rather, you could divide these into equal parts as well, but it's just additional work. I've got the construction done. We're just trying to project them across. Great. So now let's draw our straight line elements, and we're actually going to extend them beyond ABCD. So that'll find points on my curve. 1, 2, 3, and the opposite way. Okay, so I've found my elements there, and I might label them in a while. We might come back to that. Okay, but what they asked us to do initially was draw the elevation and include the elements, and I've drawn that elevation including everything they've asked for. So that's part A done. Project an end view of the hyperbolic paraboloid surface ABCD. So we want our end view. I'm going to project across, and we're going ABCD. So ABCD to begin with, and we'll use that then to find our hyperbolic paraboloid. C. All right, let's go B. Add a little bit more, maybe to there. So D there. All right, C is 45 from there. And a further 200. 45, 65. All right, so I've got point A. This is GB, and this is C. So I'll draw my element there. ABCD, found. Okay, now I want to find these elements on that. So I'm going to project across. So I've got my elements. 1, 2, 3, 4. All right, and I've got my straight line elements. Okay, we're going to start drawing them up then. Okay, so from here we're going to draw out through there. I'm actually going to extend that for now up to the next one. extend it, next one, extend it, final one, extend it. Okay, and that will find us our hyperbolic paraboloid. Okay, so we've got our hyperbolic paraboloid flowing kind of in here. Okay, so we're just kind of following the straight lines and just taking a little curve off of it. Right, so that's our hyperbolic curve. All right, and B, created. It's finished. Now, complete the end view by extending the elements of the hyperbolic paraboloid. Show clearly how to locate point P. Okay, so point P, I should have labeled down here. There's a point P down here somewhere. Okay, that probably doesn't need to be in heavy, that should be hidden detail. Okay, so point P is going to be somewhere across there. Okay, now I've extended my elements. Okay, so you can see I extended them here, most of them here already. So we just need to find a corresponding element. So I'll start at the top. Okay, I got this element here, right, brought across. So here is where that meets the curve. So I'm going to bring that point across onto that same element. I have a point. Here's my next element, and that's coming onto the second element there. Bring that across. Here's my point. Here's my point. Next element will be there. Next element will be there. So let's follow them along. Okay, so that brings us as far as all the points that we have, okay, or all the elements we have. Okay, so we need to create more elements. So I'm going to extend BC and see where that takes us. So BC extended, project that across, and I need to extend BC. So BC there. It's another point. Okay, now we're at a point where we've run out of elements. So we're actually going to create another section of elements down here. So I'm going to extend DC. That distance we have between each element here, I'm going to step off. Okay, might even do that a second time, just we might need it, we'll see. And now I'm going to do the same with AB. I'm going to extend that and that distance between each element. And we might even find that there. So we'll create another element here. Another element finding me another point. And we will have another one out here. So let's see. Okay, they're not perfectly aligned. No, it's pretty much aligned. Okay, we'll deal with that bit in a second. Okay, so first of all, we've got this element that we need to find over in this view. All right, so what we're going to have to do is we're going to have to step off, find that point down here. Okay, so project across along. If we extend CD, that has found us that point there. And if we extend, DB, or sorry, AB extended, here was the end of that element, so here's AB extended onto that. So now we can draw another element. which finds us this point. Okay, so now we've got our curve, but we're still looking for point P. Okay, point P. If I extend on that down to there, that'll find me point. If I extend it, yeah, perfect. So I've extended AB. Here's where point P will be. So there is, not point, there's where point P is. So I've extended and I've found, if we go beyond P, where a point will be. So I've extended AB. All right. If I bring this back onto that line, that's where P will be, or sorry, where it would extend as far as. So now if I draw this curve, I'll find exactly where it crosses the horizontal plane. That will be exactly point P. Yeah. So here's my curve. Great. So now I found point P exactly. By just bringing that across. All right. And I'm happy enough for that. Yeah. Okay, so clearly found point P and I've got it by extending all the elements. Great. So part D. Show the curvature of the surface when intersected by a horizontal cutting plane passing through DB. Okay. So if we take a slice across there and look at it perpendicularly, what is the curve that we will see? So if we take a slice here and look down on top of it, so a plan view, we should see it, and that will be the slice there. So it's going to be something like slice across there, and we'll project down an x1, y1. We can take our distances from here, or we could, yeah, we could do a plan view of that. Right. So there's two options there. So let me get my section. Cross BD. That's my section, and here is the corresponding section. Okay. So we'll project down points that we have on that. So all of these elements create a point, which I'll just highlight them. Here's a point, point, point there, there. We need all of these, probably not. Go for that one. There and there. Okay. So project them down. Or up if you space up, it's fine as well. Okay, my x1, y1, or will I project that way? No, I'll do an x1, y1. So x1, y1, x1, y1. Okay, so here are my points. 1, BD. That is that element. So we'll be marking off those elements as we go along. Okay, so I'll create a datum here that I'll take distances from. So distance to here Swing that arc. Now equally you could have started on that point, that's fine. So it's a BD, B, D. Okay, now we've got this point here, which is on this element. So if we follow that element over, it's this element here. Okay, and they'll be in line with each other, they're corresponding. So let's get that. Follow it down, step that off, step that off. Alright, now we're on to this point, which is on this element. So let's find that element here. Here it is. So that's my next set. So that's my distance. Follow it down. It's corresponding on both sides. So 1 and 2. And then finally we got this element here, followed across, it's coming up, so that's onto here. So get that distance again, follow it down, swing an arc, and swing an arc. Okay, and technically there's another point in there, but there are so many it'll actually work out. Just we'll see it within our curve. Okay, so starting here, freehand curve. All right, so here's my section view. So start off. So I've got curvature, horizontal curvature. Yeah, so that's that completed. Okay, so here was our our structural forms question in 2024. Not a bad question if you've experienced doing multiple questions in your revision.